I am Dr. Assoc Associate Professor in Mathematics in BLJS College Tosham. BA B.SC 6 के मैथमेटिक्स पेपर 3 डायनेमिक्स में चैप्टर 5 न्यूटन्स लॉ ऑफ मोशन पर लेक्चर दूंगा। Introduction of this is the whole structure of mechanics has built on a few basic laws which has been developed from careful observation of certain physical phenomena and experimental evidence. In this chapter, we shall study the following laws which are considered to be the foundation of mechanics. Newton's law of motion, Newton's law of gravitational attraction, Newton's law of gravitational attraction. Before beginning this discussion, we define mass, momentum, and force, which form the basis of these laws. Mass, what is mass? The definition of mass is mass of a body is the quantity of matter it contains is called mass. Mass of a body is the quantity of matter it contains, and unit of mass in FPS system, foot-pound-second system, the unit of mass is pound. In CGS system, the unit of is gram, and in MKS system, that is standard international system, the unit of mass is kilogram. Second definition, momentum. Momentum of a body is the quantity of matter possessed by the body. The momentum of a body depends upon its mass and velocity and is measured by the product of mass and velocity of the body. Thus, momentum equal mass multiplied by velocity. The unit of momentum is pound feet per second in FPS system, gram centimeter per second in CGS system, and kilogram meter per second in MKS system, SI system. Next definition is of force, the main fundamental definition, force. A force is an action which can be called an agent pull or push, which acting on a body changes or tends to change the state of rest or of uniform motion of the body in a straight line. Next definition which we required is impressed forces. The external forces acting upon a body are called the impressed forces. The mutual force of action and reaction are called the internal forces. Newton's law of motion. There are three laws of Newton's law. The first law of motion, its statement is every body continues in its state of rest or of uniform motion in a straight line unless it is compelled by impressed forces to change that state. According to this law, a force is necessary to change number one, the state of rest of a body. Number two, the speed of a body moving in a straight line. And number three, the direction of motion of a body without even changing its speed. The statement of first law of motion contains two parts, that is, as long as no external force acts. First part, a body at rest will forever remain at rest. Second, a body moving uniformly in a straight line will continue its motion in the same direction. Thus, according to first law, a body has no tendency of itself to change its state of rest or uniform motion as long as no external force acts upon it. It is also called law of inertia. Law of inertia. The second, Newton's law of motion. The statement of this second law of motion is the rate of change of momentum is directly proportional to the impressed force and takes place in the direction of the force. To prove that force, which can be written as mass into acceleration, or we want to prove an expression P force is equal to m mass multiplied by force. So let an external force capital P acts on a mass small m moving with constant velocity v. Then according to the second law of motion, we have P proportional to P equal rate of change of momentum, or P is proportional to d by dt of mb, because proportionality can be equated by a constant of proportional, that is P can be written as P is equal to K time d by dt of mb. Now because m is constant, it can be taken out from differentiation, is equal to K into m dv by dt, but dv by dt is an expression for acceleration. Therefore, we can write it as K into m into f, where K is a constant of proportionality whose value depends on units of P, M and F. If the unit of force is so chosen that it produces unit acceleration while acting on a unit mass, that is if P equal 1 when m equal to 1 and f equal to 1, then from 1 equal k time multiply by 1 multiply by 1 implies k equal to 1. Hence equation 1 becomes P equal mf, which is called the equation of motion. It may also be written as F equal P by m. Corollary: if there is no force acting on a body, that is P equals 0, then F equal to 0. Thus, in the absence of an external force, the body will continue to be at rest or move with uniform velocity in a straight line, which is the first law of motion. Hence, we can say that Newton's first law is a particular case of second law. Before going to third law of motion, we will explain the principle of physical independence of forces. The second part of Newton's second law of motion states that change of momentum produced by a force takes place in the direction in which the force acts. This leads us to a principle which is usually called the principle of physical independence of forces. It states that each force acting on body produces an effect in its own direction irrespective of the pressure of other forces. The third Newton law of motion statement of this law is: to every action there is an equal and opposite reaction. By action we mean the force exerted by one body on the another, and by reaction we mean the force exerted by the second body on the first. These forces are equal in magnitude but opposite in direction. That is, When a box is placed on the table, the box presses the table with a force M into G downwards, and as a reaction, the table presses the box with a force R upwards, so that R equal M into G. Both R and mg act along the common normal in opposite directions. The second application of third law of Newton's is how do we walk? Every time we place our step forward, we push the ground backward. By the third law of motion, the earth pushes us forward because the mass of man is negligible as compared to the earth, and assuming that the ground is not smooth, there is a force of friction which resists slipping. We move forward due to this force of friction, and the motion of the earth backwards is negligible.